Alright, so let's take a look at this 6 marker talking about the waves required practical. Figure 1 below shows the equipment a teacher used to determine the speed of a water wave. The equipment included a ripple tank filled with water, a wooden bar that creates ripples on the surface of the water, and a light source which causes the shadows of the ripples onto the screen below. So you can see there, this is the screen underneath, and you can see the waves there on the screen because the light is shining onto the ripple tank. Cool, so now it says describe how the equipment in figure 1 can be used to measure the wavelength, frequency, and speed of a water wave, and it's for 6 marks. So basically 2 marks for wavelength, 2 marks for frequency, and 2 marks for speed. So we need to define how we're going to calculate each of those. So let's start with wavelength. A good way to do this will be to take a screenshot of the screen at a particular time, because if we don't, the waves are constantly going to be moving across and it's going to be hard to get a read on it. So what we would want to do is take a photo to kind of freeze the image, and then we can kind of count the number of wavefronts and then find the wavelength from there. So let's say take a photo with a camera to get a frozen image of the screen. We then want to count the number of wavefronts, but to do that first we need to know the distance between all the wavefronts. Yeah, so we're going to measure distance all the wavefronts using a meter rule. Then we want to count the number of wavefronts, divide the distance by the number of wavefronts to get the wavelength. So count the number of wavefronts, and then I can say wavelength equals distance divided by the number of wavefronts. There we go, so that's for wavelength. So next we'll go on to frequency. Okay, so for this, we're going to want to determine the number of waves that pass a point each second. That is what the frequency is, right? So we're going to need to look at how many waves pass a point per second. So to do that, we're going to measure time. So we need a stopwatch, and then we're going to say for a certain amount of time, count the number of waves that pass that point. Okay, so let's say using a stopwatch, count the number of waves that pass a point in 20 seconds. So I've chosen 20 there, but you want to give a nominal time, something that isn't too short, but obviously not majorly long either. So 20 seconds sounds about okay. Now we want to divide the time by the number of waves that will give us the time for one wave, which is known as the time period. So I'll say divide time by number of waves to find time period, capital T. And now lastly, to calculate the frequency, the equation that links them both, F equals 1 over T. And there we go. That's how we calculate frequency. So that's 2. Now we want to move on to wave speed. Okay, so now that we have the frequency and the wavelength, we can just use the wave equation because we know V equals F lambda. So I'll say calculate using V equals F lambda. And there you have it. Quite a few points we've written down there, but more than enough to get you your 6 marks.